Where we left off in the last video was r squared cosine squared theta plus r squared sine squared theta is equal to r squared. Okay, now again, because we had a circle of radius r, we're assuming that r is bigger than 0, so we're talking about an actual circle instead of just an infinitely small point. So in this case, you can actually divide all the terms by r squared, and you just get cosine squared theta plus sine squared theta equals 1. Now notice this has nothing to do with r, so this works for any circle. Any circle of any radius will give you this relationship. So if you take the cosine of some angle and you square it and you add it to the square of the sine of that angle, it will always equal 1. This is something called a Pythagorean identity. I'll give you one chance to guess why that's called a Pythagorean identity based on the last video. So identity. Now, there are other Pythagorean identities, and that's what we'd like to go over next, because this is really the starting place. If you want to talk about trig identities, this is where it starts. Okay, so what do I mean by that? So I'm going to rewrite it in the more traditional form. Sine squared theta plus cosine squared theta is equal to 1. Okay, so how do we get from here to the other identities? Well, we actually just divide. So imagine what would happen if we took this and we divided every term here by sine squared theta. Because, whatever you do to one side, you got to do to the other. Totally legal. I mean, I could have just added 6 or divided by 17 pi, but I just decided to do this. So what is this? The first term here gives us 1. The second term, well, we know sine over cosine is equal to tangent, so cosine over sine, that's equal to cotangent. So this is 1 plus cotangent squared theta is equal to 1 over sine squared theta. Well, that's like 1 over sine times 1 over sine. We know 1 over sine is cosecant, so this has got to be cosecant squared theta. Cool. So we know that's also true. The cotangent of an angle squared plus 1 has got to be equal to cosecant squared theta. Another way you could write this is cosecant squared minus cotangent squared is equal to 1. But that's another identity. Let's see, what else do we got? So we got sine squared theta plus cosine squared theta equals 1. Well, let's try dividing by cosine now. So if you divide by cosine squared on both sides, what do you get? Well, over here we just get tan squared theta, cosine over cosine, that's just 1. And then 1 over cosine squared, well, that's secant squared theta. All right, so there's another Pythagorean identity. Starting to see how this works? So we got 1 plus tangent squared is equal to secant squared. You have 1 plus cotangent squared is equal to cosecant squared. And then if you start combining them, you can get awesome stuff. Now, do you remember what we said last time? We said that 1 plus cotangent squared is equal to cosecant squared. Okay, I'm just going to have to do a doodle. So you're starting to get the gist on how to work with trig identities. Notice what I did to one side and what I did to the other were equal. So what I was doing was never actually changing the value of the equality. I was just manipulating it so it looked different. Now, again, if we go here and we convert back to sines and cosines, this is equal to sine squared theta over cosine squared theta plus 1 equals 1 over cosine squared theta. Okay, now if we rewrite this in terms of a common denominator, that means we want to rewrite the 1 here as cosine squared over cosine squared. So you end up with sine squared theta plus cosine squared theta over cosine squared theta is equal to 1 over cosine squared theta. Multiply both sides by cosine squared theta. Oh, and look at that, we're back where we started. See, they're equivalent statements. We can go one way or we can go the other way. That's the beauty of trig identities. So, method number 1, convert to sines and cosines. What we're going to be doing over the next couple days, actually mainly this week, is we're going to be verifying trig identities, talking about how to work with them in a way that keeps the information, so you're still saying the same thing, just in a slightly different form. Because as we move into calculus, you'll find that trig shows up a fair amount, but not always in the form that's most usable. So your homework for this evening is just applying some basic algebraic moves, tricks towards trig statements to see if you can come up with equivalent forms. If you have any questions, feel free to rewatch this video and the last video. I know it's a shorter lecture for today. Remember, we're meeting Tuesday, that's tomorrow, July 20th at noon on Skype, so make sure to be there. Again, any other questions, the tutor mentors will be available tonight from 5 to 9. And as always, you can feel free and ask me questions too. So, all right.